Okay, so yeah, so it's like today's Wednesday night, and it's Angular APEC meetup, and it's a great honor to have Greg to visit like Angular APEC meetup to teach us how to write tests. I mean, clean tests in Angular. So test is really hard. Like everyone wants to write unit tests and E2E tests in Angular, like at the beginning, and eventually a lot of teams like give up because the tests are very hard to write or hard to maintain. So so testing is a big subject. So I'm really excited to learn it today, and apparently a lot of people are excited because they all come on time. So I don't want to like take more time, and Greg, you can start like your presentation at like any time you want.
Sure. Okay, I'll do that. So maybe first, let me introduce myself. My name is Greg. I'm CTO at Cobiro, and I'm passionate about tests. By the matter of fact, actually, everyone who comes into our company, the first thing they learn is testing because we take it very seriously. It's part of our cultural values as well. So generally, when I started to build the office here in Poland, Warsaw, the most important thing was like, do you actually test? And then if you don't, do you want to test? That's a very important question. If you say no to that, well, we probably don't hire you. But if you do want to learn test, then that's a great place to actually be because we really look into it seriously. We look into it so seriously that we don't even worry about the code coverage anymore because we don't consider that being the most important thing when you actually do tests. So we follow the test-driven development approach in which we actually start with the test before we code, and then we do the whole spinning. We write the code and then we refactor, and so on and so forth. The reason for that is because it's not about actually coding and having code coverage. It's more about you want to think before you code, and then you write better code. Actually, the real benefit of TDD and how we work is that the code is better. So when I have two developers and one is doing TDD, the other one is not, the end results, it's working the same, the features are met, but the code written with TDD is always better because it's testable by default. Okay, so let me have a presentation, share with you so I can dive into it. So here we go. Yeah, so I will be looking a little bit here because this is where I have my second screen with the resolution. But guys, if you have any questions or you want to ask me or say whatever, feel free to interrupt me. So no problem about that. All right, so let's talk about what you will actually learn today. So we will start with a little bit of a theory behind testing, and it's necessary to actually do it. Then later we will talk about clean test case. What does it mean to have a clean test code? Because we talk a lot about code. We talked a lot about clean code, how to have your code clean, but actually you should treat your test the same way you treat your code. Don't just, test is just to, have test cases. No. It's code as well. It's just test code. And then how to test Angular and keep it clean. And then what are the testing techniques? Okay, so let's start with a little bit of a theory. There is something called quadrants of testing. So what you want to know is you have different types of tests when you want to deliver a feature. And you can divide them into two different vertices. So here on the top, you have business facing, and then here you have technology facing. And then on the right, you have something that critiques the product that you're building. And on the left, you have a supporting the team. So the very common approach is to focus on Q1 first. It's because it's supporting the team and it's also technology facing. So we are engineers. This is what we like the most. We like something that helps me and my team, and also that is focusing on technology. The issue with that is the business doesn't see it. I mean, they know it's important, hopefully, but they don't see it. They can't really interact with it because it's unit tests, it's component tests, it's like integration tests, and they don't see that. It's not tangible for them. But you as a developer, you actually write that. And if you write it very well, you can actually show it to your product owners and they can actually understand it. But we're going to talk about it in a second. Then we have a Q2. This is when we're still in automated fashion. Some of it is manual, but generally it's automated test. It's still supporting the team that builds the feature, but it's also business facing. So this is where you have your acceptance tests. This is where you have your end-to-end tests. This is when you have the test that actually someone with a little bit of knowledge of like some public APIs, maybe you wrote some nice page objects in your Cypress, then they can actually see it, execute it, interact with it, change it without a very strong technical knowledge. But it's also giving a lot of value for your team because you know the features you built, they are being validated, and you know they are working very fine, right? But it's also about around building the features. Then we have something that critiques your product and your setup. And here in Q4, you have things that are technology facing and product facing. So this is all your performance testing, load testing, security testing, and all ELT testing. What is ELT? These are non-functional requirements. As an architect, you should actually write those down before you write any project. So these are the things like scalability, availability, portability, security as well, even it's only ET, not ELT. But generally, that's those kind of things that you wanna, something that is sort of, it's not functional, but it's non-functional. This is something like a guiding star through your project, So you wanna test those things because, maybe the feature is working and maybe the feature is actually tested in unit test, but maybe it introduced it, I don't know, maybe set timeouts or multiple callbacks, and the whole product is actually feeling slow. So this is why you should also work with your tools and automated tests to support the performance and load testing. You can automate it. Obviously, you wouldn't do it on every single commit push. You would do it maybe one time a week or one time every release. Don't do it like multiple times a day, right? Because they are very slow to execute. And then you have manual testing. So, I'm really geeky on automated testing, but I do believe manual testing should also exist. So hear me out. But manual testing is not a manual tester sitting and clicking a product. That's not how it should be done. The manual clicking should be done through end-to-end testing. Obviously, there are a lot of challenges with using drag and drop features and things that are really hard to click and move on your website. I get that. That's hard, but it's solvable. Then that's all that should happen here. Here in the manual testing, what you should do, well, ideally, it's business facing. So ideally, it's done by some product owners. In our company, it's done by product owners. So what they do usability testing. So they actually, when they want to launch new feature, or maybe the feature is already launched, then they want to actually test if the users are doing, they're using the software it was intended to do. So, things like maybe checking your Hotjar and seeing if actually the new feature, improves your conversions and stuff. Then also things like A/B testing, you want to have alpha and beta. You have two different scenarios. You don't know which one is better. So you code both and then you compare them with each other. So you do it sort of, on a manual basis because your user manually actually clicking the UI, right? And then you also have things like, exploratory testing. So we do it on the demo. So when we have a demo on the end of our sprints, we would sit down and say, okay, click it through, show me. And then hopefully it inspires our users and stakeholders to actually come up with new way of doing things. So that it's not whether it's working or not. We already tested that multiple times by machines. It's actually to explore new ways of using your product. Because when you actually feel it and click your product, then you say, wow, okay, maybe that feature would be cool. And it creates a really tremendous value. So even though I love automated testing and we should do everything automatic, there is a huge value in manual testing as well. Okay, let's get more to this technology-facing tests and supporting the team. So there is a theory called pyramid of testing. So we have different types of testing, and let's start with a bit of a introduction. So on top you have your UI testing. These are your end-to-end tests. These are the tests that, Cypress, Protractor, whatever you want to use. But these are like, testing whole journey of your users, whole paths. You can have a happy path and sad path and alternative paths in your software. You want to test it from the beginning the user logs in to actually purchases the product. If it's an e-commerce, for example. Then you have integration tests. These are the tests that are also very important, and these are in connection in Angular world. These are the tests for your services. These are the tests that will go ahead and check if your connection with your backend is working correctly, and I'm going to go more into details about that. And then we have acceptance testing. These are the tests that will test the acceptance for your test, for your code, regarding the business logic. So this is where you're going to go in and say, hey, I want to test if, validate if my business logic is sound. So you want to use some, maybe you could even use a Gherkin language, given when then, and write the scenarios in plain text that will actually translate to code, test code. And then we have the most, and, I consider them the most important and fundamental, the unit test. And the reason why it's made the pyramid is because it tells you should have the most tests is written on the bottom, and then the end-to-end test should be only cream on top, right? So make sure you have a solid foundation of unit test. And a lot of times people will fall into anti-patterns. I'm going to talk about them in a second, but generally try to look at this way. Like the lines of code that are being covered in your unit test should be the most. Okay, so let's talk about them and differences between them. Why is it like this? So let's talk about the unit test. What do we know about them? Well, unit tests are small. They are small in scope. They test one function, one invoke of a function in a class, or maybe the whole class itself, and that's it, really. It also comes into the decorators. I'm going to put it in the Angular word in just a second, so just bear with me for the bit of a theory. What you need to know about the unit test, they are small, fast to execute, and give you very specific feedback. So it means that if I have 1,000 or 10,000 unit tests, they are executed very fast, and they give me very specific feedback. It broke on that line, for example. That's very specific. And then they are small in scope. So you don't test, everything using unit test. You just test a specific thing. So if they are so cool, why not only do unit test? Well, because you test only one part, and then there is another part also being tested. You also want to test that these two features work together with each other. So this is not the scope of unit test. Unit test every single thing, but you also want to combine them and test things work together. So an example of unit test could be, I don't know, maybe you have your model classes, maybe you have your directive, maybe you have your presentational components and types. So everything that has an Angular decorator, that's for me a scope of a unit test. So if I have a presentational component that has a TS file and HTML, I would test these two in one, and I consider this as still a unit test. Okay, then we have integration testing. So what do we know about integration testing? They are also relatively small in scope. So there is a bit of a misconception, just FYI. When I talk integration testing, I mean actual testing of your services that work on the edge of your application. I'm going to visualize it in a sec. But generally, it's not integration testing in terms of integrating many modules together. That's something else. I call it acceptance testing. But in generally, integration testing is where you actually need to communicate with the things outside your application. That's what I call integration. It's between the apps and between backend and the front end and stuff like this. It's not in regards to between the modules of your maybe NGRX store or something like this. Then what also we know about integration testing, they are slow to execute. So in regards to unit tests that was fast to execute, these are slow to execute. Why? Because you need to set up your infrastructure. So you need to set up a mock server for your backend and things like this. So it's not as easy, and it's very often asynchronous, and there's a lot of trouble with that as well. And then, but they give you very specific feedback. If something breaks, it broke in this service, in this file, in this method. Okay, what are the examples? Well, HTTP service, you can test it like this, WebSocket service, GraphQL service, local storage if you wish, IndexedDB, whatever. Okay, then we have acceptance testing. This is when you test your business logic in combination with other modules. So this has a medium scope. So you test the entire layer, for example. You don't test only one class, you test entire layer of your code. And then you also, they are relatively fast to execute because they use the unit test framework for this, most likely. And then they give generic feedback. You don't know what line of code caused that. Literally in a call stack, you can look at it and say, oh, okay, it broke there, obviously. But the thing causing that is somewhere in the bottom of your call stack. So actually, it's not very specific feedback. You can know which functionality broke. You can say login the user broke, or you can say registering the user, or maybe adding the product broke, but you don't know exactly which class caused it. Then you have to execute your unit test and ask for specific feedback. Okay, what are the examples of that? Well, it's, for example, application layer. So you will have NGRX store with selector, reducer, and effect, testing all that in combination. Or maybe command bus and query stream. I know not many people probably heard about command bus and query stream. It's some sort of an open source. Well, it's closed for now, but it's going to get open source soon by Cobiro. It's an alternative to NGRX, but generally, it's think about it as like NGRX store. I think that's the easiest way. This is not a talk about command bus, so maybe somewhere in the future. And then also container components, like your whole pages and bigger scopes containers. Smart components as well you can test using acceptance, which are more complex. Okay, and then you have end-to-end testing. You probably know that. You work with Cypress probably. It's a great tool. And then we go with the large scope, entire app. And then we do, they are slow to execute, as you know. I mean, you need to spin up the whole environment, web browser and so on. And then they are having a very generic feedback. You also don't know exactly what broke and where. Okay, so what are the examples? Cypress and Protractor, you test the entire app. Okay, there is an anti-pattern. So you remember the pyramid of testing? These are cool things. But then when you do opposite, it will be called ice cone of testing. And it's good if you don't have any tests. So start with end-to-end test first on top, and then go into more unit test and start eating the ice cone from the top and work on your unit test. That's very important. But if you have only end-to-end test and you have a big code base, it's not a good thing because things will take very long time to execute. It will be very expensive for you to run your infrastructure and so on. Okay, so let's get to the clean test. I just have a question like, are we very strict on 30 minutes rule? Because I might go over time.
No, it's okay. I mean,
okay.
If the other people need to drop off like right at 11 p.m., then you can drop off. But the meetup can go as long as you want.
Okay, so, sorry for that. It's a lot of topics. I'll try to run through as fast as I can. So there is something called given when then. So given when then. So back in the days, like 6-7 years ago, when I was learning about testing, someone came to me, an architect, and said, "Listen, there is something called AAA rule. So arrange, act, assert. Given when then is exactly the same. It's just reframe of the same thing. So generally, you will have given stage where you set up your test. Then you have when you actually execute something, and there is only one when per test case, per it statement. And then there is then, and then you can test multiple things, but generally on the same one single object or same one single layer, right? So given is optional, when is required, and then is absolutely required. Okay, I'm talking a lot of theories, and you probably say, hey, give me some more example. So here we go. I always try to be more tangible with my presentation, not to go like theoretical only. So let's get to the meats of it. Okay, cool. So let's go. This is a Okay, so this is a layered architecture. I took it as an example. Obviously, there could be many more than that, but this is like a bread and butter of most of the Angular applications. So you will have a top layer which will have services. You have a middle layer which will contain your store, selectors, and command bus in our case. But generally, there is a state in between. Sorry, there is a state inside. So actually, service never really interacts directly with, a component never really interacts directly with the state. It has a store or selector, right? And then the state, hopefully, can use some effects and reducers, and then it will have injected the services, right? So generally, these are the three-tier layer. So infrastructure layer containing HTTP services, state application layer containing state and store and selectors, and then the presentational layer containing component and directives. Here we go. So how do we do it? Component, a unit test. So we will have component TS and component HTML testing together. So we're talking this layer here, the red border shows you this. So what do you need to know? Well, you need to know that when you set up your components, you don't wanna drag with the test case all your states and services. So when you set up that thing, you wanna really make sure that you have a stabbed version of your store. So when you use store, it's already very handful, and GRX is really great about actually providing you, all the test features for this. But if you don't have that, or maybe you use only service, make sure you create something called an Angular test module. This is a very common example. I'm going to talk about it in a second. But generally, just make a line in between the components and the rest of the application. Test in isolation. Don't drag. If you look at your test bed and you have to include all your, NGRX in there, that's not good. Because you're bloating your test bed with a lot of imports, and it's getting slower. And when something breaks with your state, it will actually break your component test. You don't like that. You like to test only this one specific thing. So this is an example. Actually, these days, I would really, really strongly encourage you to use test harnesses for this. They're a great tool. You can find them in Angular components in the CDK testing library. We have, before harnesses came to life, we had this example. So it's slightly outdated, but generally it's very similar thing. You can see we created our own harness called fixture DOM selector, and that will encapsulate the model, the object, that the component actually that I'm actually testing, right? So generally here we have an example that it should call set method from manages language service. So I have a service and I have my component there. So in my given state, I will set up my spies on the language service on the set method. Then I will go in and say fixture DOM selector, select by data selector. Data selector is an interesting pattern. We never really select by CSS classes because, one of the UI guys will come in and change the CSS class and my test will crash, right? You don't want that. So what we do instead, we create something called data selector attribute. It's actually data-selector attribute in HTML. And this is an agreement between the developers and product people and everyone that this is used for testing. We don't use the IDs, we don't use the CSS classes, we use an extra selector called data selector. It's really keeping us clean, and it separates the UI, the presentational, from the testing. And also in the production code, we can strip that. So we can actually have a preprocessor that will just remove it from the production code. But it's great for testing. It's great for end-to-end testing as well. So we have the same context in both unit and presentation and end-to-end testing. Then we have the trigger event handler change, and then we say, because it's a dropdown, and then we say, find the object with the language code DE, which stands for German, and then make sure that we actually call the language service set method on it, that we spy on it, and it was called with the DE. So you can imagine how the code looks like. Well, the code actually, the HTML will be a drop-down with the options fetched from the service, and then it will, on the change event, it will call the service from the component. But here, when I look at this test, I don't see those information. I just see sort of a UI that I interact with, and then I can select it, and it calls a specific method. So if you use store, that will listen to changes on the dispatch method, invoking a specific action. So that's pretty cool, actually. Why do we do it? So what are the anti-patterns with it? A lot of people will just test the component TS file. So what it will do, it will say that, let's just imagine that this change handler has some, on input changed in the component. So it will invoke that component method on input changed, and that way it will actually check if the dispatch action was executed. Sorry for the sounds. So yeah, that's not good because you don't test your template. So if you change something in HTML, the test will pass, but actually application will break. So always adjust your unit of work as much as you can in your tests. Like the broader the better, but keep it in a scope of a single class, right? Cool. This is an example of how you can test directives. So we have the directive code on the left and the actual test code on the right. So we have the SVG icon directive here. So you can imagine it just adds SVG. Then we have the renderer and element ref, attribute directive at its finest. And then we just, on init, we set some properties, right? So how do we test it? Well, we have to set it up, as I said. And then this is interesting pattern because we have something called test component. This is a presentational layer, right? Like it's not a component because it's directive, but it's like a presentational component. So normally you want to test everything. You want to test that the input was binded correctly. So what you do, you need to create something called test component that as a template will contain that directive. So I have SVG, CBR icon SVG, which stands for this directive. And then I just want to pass inner HTML. So in my test, I will create an extra test component that wraps around that piece of HTML, and then I will test that component from the outside. So what I would do is it should add content to SVG and set styles and attributes. So on my fixture DOM selector, I want to select the SVG, the part of the HTML, and then I want to check that the SVG attribute was actually set like I intend to through the input parameters. So now I tested, input in, input out, and that way, if someone removes this input decorator, the test will actually crash, and that's what I want. I want to crash it when someone makes some sort of a mistake, right? And you see, I don't explicitly say that ng on init should execute that. It's sort of obvious. If someone moves it to, I don't know, maybe setter on the input or somewhere else, the code should still pass. So I should be able to change the internal of my directive as much as possible without affecting my tests. This is very important because there is something called brittleness in your test. So when you change code and every single time you change code you have to change tests, something might be wrong with your tests, right? So you wanna, to some level, obviously, if you don't change your APIs, if you don't change how inputs are named and stuff like this, you shouldn't be really changing. If I change this line of code here, maybe, I don't know, I don't want to use renderer. Maybe I want to use element.native element dot set properties on it without the renderer. I shouldn't be testing my test because this is implementation detail. The outcome should be always the same, HTML with SVG element. Hope it makes sense. Okay, let's talk about services. Services is actually something that a lot of people test very incorrectly because how even the Angular documentation will tell you, hey, you can use HTTP backend and you can have your special testing client, and then what it really does, it's actually testing the services in unit test way. So it will test that your service that has client injected actually execute a correct. That the service has a client injected and the service is calling the client correctly. That's cool. That's some sort of a value unit test way, but actually there is a better way, and we use Pact for this. It's really awesome tool. Check it out. So you see this diagram, I need to expand it a little bit further because the service is not a service itself. A service is actually something that connects with the server, right? So most of the cases, but let's assume there is some HTTP. Yeah, it's amazing. I really like it. So I have my mock server. So what is mock server? So check it out. What if I could, in my test, set up something called mock server, which would actually literally create a server, real server, HTTP server on my local machine or maybe my CI environment. It will create a service. And that way, when I want to make a call, my service will not know that I actually called the mock service. I just changed the base URL somewhere else, maybe in my proxies. And then I will call that mock server instead in my test environment, but in a production environment, I will call my real servers. So, and the mock server, I could set up in my tests that when I call the mock server with that set of HTTP request verb and parameters and headers, it will respond with this. Otherwise, it will fail. So check it out what you can do. We're also going to open source it. We created a wrapper around Pact. So imagine how easy is it for us to write those tests? Because you see, you need to treat your test code like your real production code. If you create, abstraction layers and models and stuff in your production code, do the same for the test code. It will pay off. The number one reason why developers don't write tests is because they are hard to maintain. And if you really give some love to your tests, they will pretty much be easy to write. And that's what you should do. So check it out. What we did, we created a Pact request that is encapsulating easy API in actually creating this. So what we say, hey, I want to make a request, and I say request methods.get on this URL, and then the body is null because I don't pass any query params to it. It's just a get. And then I create my JSON API headers. We use JSON API. It has some specific headers. We already have a const for that. Okay, so I tell mock server, please, when you receive a request like this, respond me with this. We respond with Pact response and say, give me OK status code, give me the response at already prepared, body of the response, and then respond with these headers. And then I can use something called provider state. This is very advanced topic. I'm not going to go into detail with it. But eventually one day, if someone is interested, I can make a whole talk about Pact. But generally, just think about it as some unique ID of this interaction. So this is an interaction. Interaction is a request and a response. And if this passes, all I have to do in my test is to call that method and subscribe to it, and that's it. And when I do it, the Pact server itself will say it's true or false. If it's true, I pass my parameters correctly. It will respond me with the code. Then I can check my mappings, map my service, and then return it. And then things are working fine. And what's cool about Pact? Cool thing is, this same interaction will go into our backend. And our backend developers now can verify. So we always keep things in sync. So if the backend guys change something, well, they can't push that code. They can't merge it because the CI will shout. And then it's called consumer-driven contract. I'm a consumer of my API. I'm a developer. So it used to be, hey, backend changed something, but the product owner goes to the front-end developer first. But now things don't happen like this because I tell you what I want to consume, and you need to provide me this. And with Pact, it's actually automating the whole flow. It's pretty awesome. Because if they change something, they can't push that code. If we change something, we have to comply with backward compatibility of their API as well. We can't just change it like this. So it's super awesome. And then I can go and see all the graphs, how things connect. And, it's really cool. Highly recommended. Okay, and that's when I set up. This is all I have to do in my service. So I have my service.get method. it doesn't have any parameters. I subscribe to it, and then I say, hey, you know, that the response of ID is actually exactly the same as I set it up in the campaign group parameter, and then also that, you know, the headline has this headline, and that's it. Done. If Pact responded with the error, it will fail, and then my test will fail. The only problem is it's slightly slow. So also, you know, bear it in mind. Okay. Then we have CQS. For people who don't know CQS design pattern or architecture style, think about it as a store. I think that's going to be easy. So now we want to talk interface in, interface out, and I don't care what's inside. What's inside is tested with my unit test. Now we're talking acceptance test. Here we are. So think about it this way. We use command bus, but it's like a store. So generally, this is what I want to test. So I know how to test this. I know how to test this. Now let's get to the meat of my business. Let's talk about the application layer. So what do I want to do? I want to obviously stub out all my services. I don't want to test that together with my state. It's in separation. I already tested it with my Pact. And whatever component, whatever actions a component invoke, I want to test that in a separate test. So it's testing my dispatching action on the store, and then what goes out of it. So I spy on my services. These are not the real services. These are spies. And then if I execute user created, create user, they want to see that the post, that the method on my service to post that message, like create that user in a backend API, was invoked, or the selector came out from the other side. Okay, so it's in isolation and it's a big scope. So here we are. This is an example of the handler for the command bus for us. So generally, in here I have a command which is like an action, and say add page action, right? So I want to add page to my website, because we work with a website builder, so it has this, you know, the domain is around pages and websites and content elements and so on. So generally, what I want to say, hey, I want to create a simple page with UUID as ID, and then I want to say I want to create the title, a URI, and description, and then it doesn't have any parent, for example. And then when I call this method, it will call the service called event bus, and it will call the save method on it. So this is the implementation, right? So all you have to know is command comes in, and then it calls the event service. Okay, how's the test for it? It's like this. I want to spy on my save on my event service, and I want to create a command. I create something called stub. I'm going to get to it in a second. And then I want to test command bus dispatching. You see, if we come back here, you could be testing state itself. You could be testing your reducer. You could be testing your effects in separation. You can do that, of course. If you're really, really serious about it, just do it. But the real value, and this is a turning point for a lot of developers, is you want to test these things together, in combination. You want to test store dispatch, selector select, right? That's really powerful, because you want to make sure things work together. I'll give you an example. What if in this code, someone has this code and is perfectly sound and the unit test will pass? But what if someone didn't bind correctly the command into the reducer, right? What if the configuration of the reducer wouldn't pick up on this? The test will pass, but the code will break. That's what you don't want. This is why always go on the dispatch method, because then you also check if the configuration of your reducers and, you know, reducing the type of action on the actual handling method is sound as well. An example in NGXS, if you really like NGXS, you have the decorators, right? So at the add action, what if someone remove that decorator? Your test will pass, but your code will break because it will not find the handler for that action. This is why you want to go on the dispatch method all the time. Okay, I hope that was helpful. Are there any questions so far? Okay, so let me go to the meat of a meat. So what can we do? Well, how do you treat your code? The same way as you treat your production code. This is the #1 lesson you have to learn. Okay, here we go. What rules then we can apply to our test code? Dry rules, which means don't repeat yourself. This is #1 thing. Why dry rule is so important? Because it creates a maintenance hell. If you repeat yourself and you do copy pasta all over your workspace, you violate the dry rule. You're missing levels of abstraction in your code because you just copy paste code. And then someone comes in and says, oh, there is a new way of doing things. There's no one place to go. You go to 100 places to change the same thing. That's not cool. So keep your code like this. So how can you do it? Well, a common case is to create reusable expects. So you know those expects that you can create. You see, obviously this is the easiest you can go. Let's say I want to test a myColor class or myColor interface, whatever. Then I want to make sure that I have color.id, color.name, color.value. And now I want to do it in so many different scenarios, right? Because it's unit testing. So let's say I want to do it in 7 different test cases. I want to test if ID was not correct, or name was not correct, or value was not correct. You know, I want to test all my edge cases. Every it should 7 times will repeat the same expects. No. If you have it in 7 places, create 1 common place for it. So create one method, a constant arrow function, where you have expect my color, and then you pass in color, and then you check if it's a correct value, right? You can also add additional parameters, what you actually expect, but don't repeat these 3 lines if you can make 1. Okay, if you're really, really hardcore, and this is not good enough because you can say, you know, it's sort of like cutting code all around the place, you can extend the expect yourself. So what you can go and, you know, this is an example of, so for example, I have expect something in the brackets, and then the dot afterwards is this function, to be power off, for example. You know, you have those helping function like to be instance of, or to have length and whatever. You can actually, this code, you can say to be a color of. Okay. Another thing you can do, you can reuse your setup functions. So, you know, you can have it in your before each and stuff like this, but very often when you actually code something, let me show you an example. This is an example of the setup function, because this is acceptance testing now. So I test my store. For example, I will have my handler class, additional providers, additional modules. You see, and then I have this testbed.configuration. Look, here a lot of things are happening. So I have like application bus module interface for root. Then I have some additional modules added. Then I want to set up my command bus provider. Then I want to also set up my application event handler. And then I want to also inject some extra things and call init on it. So there's a lot of things. And this part would be creating in my before each, you know, when I want to set up my test bed, I will actually do all those lines all the time, but now I don't have to. I can have only one function called prepare application event bus handler test, pass on some parameters, and deal is done. I don't have to repeat it. That way, if my API change, or if the way I set up my application layer changes, I do it in one place. So I hope it's helpful. Always use this. Another thing is edge cases and collections. So, for example, here we go. One way of doing this, and it's actually pretty interesting. Instead of creating 5 different it statements, you can have a collection of your test case, of your input data and expected data, and then call it.each on it. And then every single array here will execute the same piece of code. It's very, very important, because, you know, because it really essentially is different input and different expectation, but exactly the same unit test that I need to execute. Don't create 20 its, just create 20 items in a collection and call .each on it. That's a lot more helpful. Okay. Then we also go and talk about the design patterns, because there are design patterns for testing as well. One of it is stubs. This is an example of a stub. It's very simple. Stub. What is a stub? Stub is static data. Think about it this way. I have my elements order collection, and it's an array of 2 items. One is called ID1 position 2, and the other one is ID2 position 1. That's it. And it's a stub. And I need to reuse it in so many places because, I don't know, it's connected to different edge cases and places, and not only one test case, maybe multiple test cases. Then I will go ahead and create a stub for it. Stub means silly, stupid sort of data structure that just contains static data. It's pretty cool. Okay, but sometimes stubs can be a little bit more complex. So what I need to do, I need to create a collection of stubs, right? So maybe I want to create my providers, providers that you just inject. One way is to use the testing module, but one other way is to just create a constant for it. And then, you can have a stub of stubs. That's also pretty helpful. But sometimes it's not enough. Sometimes you actually want to add some dynamic parameters. Maybe in one test, I want to test a specific stub value, static values, and in another one, I want to test another static values. So that way, I want to create a factory function. It's like a factory in your code. It's just that it's creating stubs. So check it out. It's like this. So it's the same thing. Instead of having an element order as a static value, maybe I want to just replace ID because my tests rely on this ID, for example. So I want to pass on a value and then create a stub based on that value. It's pretty much a wrapper around your stubs that will add the dynamic parameters into it. So yeah, it's also very helpful. Okay, assembler. If you're bored by now, I hope this is something you didn't know. Assembler is a builder pattern. So this is an assembler. Let's say I have a business logic, the business object. In this case, it's actually called business object, literally. But it's like a domain. It's like a more from domain-driven design. It's like a more sophisticated object that has some logic inside it. But because it has so many things in it, it also has a lot of dependencies on another business models inside of it. For example, in this example, I had to cut it because it would not fit on a screen. So it's a lot more complex than that. But check it out. I have interface called business, and it has 2 things called logo and Google code. So if I have this thing, what I can do, I can create an assembler that will build a business object for me. And that way I can reuse it. So, a factory function would not be enough because sometimes I need the business with the logo, sometimes with the Google code, and sometimes with logo and Google code. So it's permutation of 2, which is like 4 different options, right? If we take undefined or not undefined. But what if you have 10 items then? That's permutation of 10. You can make factory functions for it. It's too many combinations because you don't want to just say true or false, but maybe a combination of 9 items and 1 false and stuff like this. This is when you create assemblers. So the assembler works like this. It's like a builder pattern, but it's for test. So I have my object in a default state, and then when I call new business assembler, and then I can always return this on it, which means I can chain invokes of the method. So an example would be, do I have it now? The example would be new business assembler, brackets, and then I say dot with logo, pass on the parameter, dot with Google code, dot assemble, and then I return the object. If it seems a little bit shaky, maybe reading about builder design patterns will help. Because it's essentially the same, it's just called assembler, so we don't confuse it with the production code. Okay, there we go. In-memory storages. This is very important because, as I already mentioned in one of those, I tell you, here we go. If you want to test this in isolation, you can spy on the services, but sometimes you have things like storages, like local storage, for example. You don't want to actually execute the local storage in your test. You want to create maybe in-memory storage. And it's also very powerful because while I develop the state and I don't have a service yet, I can have an in-memory storage. And that way I can actually keep working on my code and then only add the layer of the services on the end. So it's pretty cool. So how the in-memory storage looks like. Sorry for changing. It's like this. So I have my abstract in-memory storage that implements a storage interface, and then it's just a dictionary, just a map. And then I can call save, get keys, find, remove, and so on. And then I can have an in-memory storage that actually extends it, and not in-memory storage that also extends the same thing. So it's pretty cool because I don't have to actually set up all the IndexedDB or local storage or whatever. I can just pass on the in-memory storage, and things will work the same way as it was, but it does not really contain the production data. So it's speeding up the things and development and everything. So it's pretty cool. Okay, testing modules. This is like the highest level you can go. So we have the, when you create a module for your directive or maybe for your components, smart components and so on, then you want to also use it somewhere else. Maybe it has a dependency, maybe, you want to test a page component that contains this. And for sure you had this problem that when you set up the test bed, you set up your container component and you say, oh, shoot, I forgot about my directives. Oh, no. And here we go. Testbed starts to grow and add things. And God forbid, if you actually had the problem inside this directive, it will fail your container test. I'm sure you've been there, done that. I got a t-shirt. So what you can do, create your test stubs. Because again, the secret of testing is testing in isolation. When something breaks, you don't want to go through thousands of lines of code. Make your life easy. Create the testing modules, then if something breaks in the directive, you hopefully have a test for that. But if something breaks in your container component, you want to get the feedback container component broke, and you don't want to jump around. So testing modules are pretty powerful and awesome. Okay, and then the data selectors I already mentioned, but you can also create the wrappers. Here we have our own example of by, which extends the platform browser by in Angular, and then we added a static method called data selector. So then this is the example when normally you say by CSS by something, but here we say we wrote our own in which we say by data selector, and that way we actually wrap around the predicate that's already done in Angular. Okay, another very important thing is to create abstractions. So as you already saw, there are some request and response objects. Abstract it away, make sure you test only very specific thing and don't repeat yourself all around the place. Also, the thing with DOM selector, you can read it harnesses, keep the harnesses, they already sort of work like a DOM selector. They do a lot of boiler code for you. You don't have to repeat yourself, create those abstractions around code. So just, look through the Angular source code, it's open source, just see how they did it. And use the same principles. So this is an example how we did it. So we have the fixture wrapping. So we have this class wrapping around the fixture, and then we have the click element, and we do, if we didn't find that element, we throw an error, and if we found it, it already deals with all the change detection for us. And then also, if we want to have a keyboard event, we have an abstraction for it. It's pretty funny because we had all that written in Cypress, but then things were slow. And then we started to say, hey, maybe Karma and Jasmine can actually do it for us. And it's been a very, very fruitful exercise. Okay, page objects, a very important thing. Page object is when you actually encapsulate part of a page. So in your Cypress code and so on. And then it's very similar to harnesses as well. So generally, page object represents a piece of your UI. And then you add an API on top of it, the testing API that allows you to call some methods, and then it already self-validates inside. TDD, very important thing, where I started. So I found myself that when I do TDD, I tend to forget to refactor the testing code. It's very important. So the TDD is test, code, refactor. And when you refactor, a lot of people will just refactor the production code. And I very often in the pair programming sessions, I will say, no, your test looks bad. And they're like, what? I should refactor my test too? Of course, yes, refactor your test too. Treat it the same as your code. It's the same. It's like, why TDD is important. Why is it even working? It's like accounting, If you ever work in an accounting system, you will understand there are two sort of entries. One is for what you spend, and one is what you get. There is no like a single active record. It's a set of two events. Either I spend or either I get the money. That's how it works. The same is with tests. The test is part of the same sort of ecosystem. Test is my what I spend, so what I get, and then the code is what I spend. So it's working together. Like they have to align together. Like there is no situation when I'm breaking my tests, right? Unless I refactor stuff and transform it. So yeah, refactor your test code. Okay, that's it. Really, thank you for staying with me so long. It's been a pleasure. Let's just sum up what we learned and then prepare your questions. We're gonna have a 5-minute afterwards. So hopefully what you've learned by now is the theory behind testing. I know I went through very fast. Then we also have the clean test case. So write your given when then states, keep it clean, keep it in isolation. Then we also how to test Angular and keep it clean. We also talk about different testing techniques and all the abstractions and the objects and stubs and so on. We're also hiring, so if you really want to work with testing where 100% test coverage is a normal thing, please go head into our website, cobiro.com/career. We're looking for developers who are willing to learn. And then that's it. Thank you. If you want to get in touch, you can check out my YouTube. You can find me on Twitter. And yeah, that's really it. It sounds easy, but it requires years of practice. So yeah, if there are any questions. Thank you, Simon. Okay, if there are no questions, get in touch with me on Twitter.
I have a question, yeah,
yes.
real quick.
Yes, please.
Yeah, it was in regard to how you were saying, like, how you go about manual testing, and right now our company is kind of in the process of turning that I don't know, that ice cream cone upside down. We've got some Cypress tests, and now we're just starting on unit testing. So we're kind of in a process now where we still have like a lot of bug tickets being created, and I was just curious about that process. Like, who closes out those bug tickets? Do you do manual verification of the bug tickets, or do you have like people writing test cases or tests based off of those bug tickets? How does that whole process work for you guys?
Yeah, absolutely. Yeah, there is actually a strategy that I advise developers to do. One thing is obviously have someone in a team or maybe a group of people working on the end-to-end tests. These people will actually offload the manual testing you have to do, right? So this is good. This is sound. Keep on that. Now, next thing you can do is to actually get developers to write code. So write testable and test for the code they actually do. So just create this, movement, this cultural movement in your company when you say, tests are good. Use pair programming for this. Use some hackathons on Fridays. Do whatever you can to actually create the cultures and knowledge sharing around tests. And then for every new feature that is written, right? So you say, hey, anti-corruption layer. This is a legacy. This is a new world. Now I'm moving to the good way of writing tests from the scratch. So everything new I'm writing is testable and tested. And that's what you cover and check your test coverage on it. Now, what do you do when the regression happens? So when someone comes in and say there is a bug, the first thing you should do is to write a test case, because then this bug doesn't appear again.
Okay. That sounds good. And when you say write a test case, I mean, generally you're referring then to the unit test, or are you, okay.
Yeah, so it depends. It really depends. Okay. So you have to identify. So actually there is a terminology, there is a thing called acceptance testing driven development. So writing a acceptance test or end-to-end test, if you will, very often it's interchangeable. It's not really, but just keep it simple. So start with end-to-end test first. Okay. If it's simple and you can write this and you already have API for this, start with this. and then while you're coding and find the bug, then cover it with the test. Because one thing you have to know, sometimes if you don't know what the problem is, it's really hard to write test first. So I wouldn't recommend it really. Do the end-to-end test, cover it, and then find the bug, fix it, and then write the test afterwards, right? Okay. And for all the new stuff you do, start with test first.
Okay. Thank you so much. Wonderful.
More than welcome. Was it, how much of the knowledge, how much of the stuff you actually knew? How much was it new? Like, was it sort of totally new? Was it relevant?
It's totally new to me. So I'm like, do you have a repo that people can go and look up the examples? I mean, like those page object and DOM selectors, like, oh, how do I make them? If I don't know what they are to start with.
Yeah, that's a good one. Actually, let me think. Yeah, actually we do. We have some open source. You can check it out. But you know what? I can give you like if you go to github.cobiro, github.com/Cobiro, you will see all our open source, and we're gonna move towards it more and more and more. It's usually about our core library, so it's not that much feature based. But I'm going to be making on my private GitHub as well. So one is our company website, and then on my private one, Radzio, you can go and see my repositories. I'm going to be adding more examples as we go, and most of this will be containing a lot of tests. And I will create some e-commerce examples and so on. So you can actually play around with it as well. So yeah, check it out on my GitHub. Yes, please.
Hi, Greg.
Hey.
Great talk.
Thank you.
I just had a question around component testing specifically. How would you go about testing a component that have other nested components? If you, for example, want to test how one component interacts with another, how would you go about that? Is it also stubbing?
Yeah, so that's a very good question. So it really depends how far you are, right? So for example, if I have a presentational components inside my smart components, then here you got me red-handed. I would not do the test for the presentational components itself. I would do the sort of a deep testing technique. I would not go shallow, only testing the smart and this in separation. I will test the whole thing together in combination. I would stub out all my directives and stuff that and maybe some services and things that are outside of the scope of that is fetching the data to my component, right? I would stub this thing out, but inside I would not do the shallow testing. I would do the whole mount of all component tree with all the stuff inside and test it together in one go. Sometimes it's a lot of work, but it's also a very interesting thing goes out of it. One is you learn to write small components because you're just too lazy to write all those test cases, right? So then you actually see, okay, I wrote like 5th or 7th or 10th test. Maybe this component is too big, because one thing that Angular developers do notoriously is they think a page is a smart component. That's not true. A page is a page. Smart component is a piece of that page that contains all the business logic. So if you learn that, your test will be smaller because the components will be smaller.
Thanks, Greg. And you mentioned that you test all the except for services and all the components together. So I mean, how do you pinpoint to where, if you experience an issue, like how do you pinpoint to exactly that it's this component, it's component A, what's component B? How would you go? How would your test actually show that information without having to debug thousands of lines of code just to figure it out?
Yeah, it's a hard one, but okay. So ideally, there are two ways to mitigate that. One is create smaller components. I already said that. And then the other one is create more it statements, because that are separate testing, separate pieces of it. So I would have one it for getting the data, one it for interacting with the data. And then I would put the getting the data on top of my test case. So this test will fail first. So I would structure my it statements, it should, blah, 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 around functionalities of that component, right? So then it will tell me that test failed. So keep many it statements and keep them short with given when then, so you know which one failed, which functionality failed. It definitely helps. Now, sometimes it's not possible. Maybe you have a legacy code, you know, maybe you just want to cover it. So that's not easy. So what you can do, I would actually go to my HTML and remove all the presentational components first, and then run the tests. And that's how I would debug it. I would divide and conquer. So I would do remove a pieces of HTML code and then see if my tests are still failing. If they are, that's a problem in my smart component. If they're not, I would add one by one presentational components and see where it fails. And then I know that's where the problem is.
Cool. Thanks, Greg.
It takes time, but yeah.
Yeah, definitely. Yeah, I've seen that.
Yeah, but hey, you know, tests are here to help you. You know, they're not the bad guy. They're a good guy. It just looked bad on the beginning, but eventually, with all these tests, like we save so much time because the debugging doesn't happen. Developers focus on coding. Once they learn how to test, they focus on coding, and it's pleasurable experience, you know? They play with the code. Hey, maybe I write that test and stuff like this. It's really, really powerful. I know it's hard to get that with the code base. That's why it's always good to start with the fresh code first, because then, you know, you can nurture it a little bit better. But hey, you know, I mean, it's exciting journey, you know, you learn so many things, and, you know, with test harnesses, it's even easier now. So it's really awesome.
Is there like
Cool,
the
thanks.
type of is there like the
Mhm.
type of engineer who specializes in writing tests? Like,
Mhm.
I mean, developer write tests, and if they don't write good tests, then maybe it's better to have some specialist to do it. Right?
Yeah, I see your point. Yeah, actually, a lot of companies will go with the tester in the team and QA and stuff like this. We sort of don't do that in Cobiro. I know it's more you have to learn to actually be a developer in our company, but it's also more interesting. And you see, what I found out with like 15 years of experience is we tend to then drop it on the tester, and the tester will drop it on the developers, and nothing gets done in a sprint, you know, and we don't like that blame game. Hey, he did that, you did that. Hey, you don't test it correctly. No, you write code bad, you know. We don't like that. So I would rather have a pair of them working together, and one writes test, one writes code, and then they switch, and then this guy writes test, and then this guy writes code. It helps with the knowledge sharing. It's so much better. For example, when I teach developers, I write test first. I just say, hey, this is test. That's how I write it. Do the code. And then we code together, you know. Now in the remote environment, we just have a code with me extension, and, you know, just code together on the same ID, you know. And it's really cool. I write the code, test, they write the code, and they learn. And then eventually, you know, okay, now you write the test, I will write the implementation. And then eventually they pick up on this, and they do all of them by themselves. Yes, please.
So, Greg, like, how do you encourage an environment where there's developers that are not actually, you know, contributing to, you know, writing tests?
Yeah.
How would you, you know, encourage that kind of environment?
Yeah. So it depends how many of them are there, right? Because I like the democratic approach, because, like, for me, it's not so, okay, since I'm CTO, I sort of lead the way of technical thing, right? So it's just part of what we agreed on the beginning, and no one questioned that anymore. Now, when you're not in this favorable situation and you actually have some people who don't like writing tests. I would say, I think we can all agree that tests are good. They are just hard, but they are good, right? So I would, it should be sort of a democratic decision of a whole team. And then, hey, you know, do we want to try this out, right? And then maybe let's try it for a week. Maybe let's try it for a couple of days. You know, maybe we're not going to stick, or maybe let's see if there is a value in it. So I think, actually, hear me out. This is going to blow your mind off. If I write wrong tests, it's better not to write tests. That's what I learned. It's better not to write bad tests. It's like, it's better not to write broken code, right? It would be better if I didn't write it, if it breaks my product. So it's the same with the test. Learn to write the test first. You know, there's a lot of resources. You can see my YouTube channel. I do TDD in my videos and stuff like this. So check it out. But it's like this. If the test code rots and creates, you know, bad experience for the developers, focus maybe on your end-to-end test first, you know, because they are easy to write, hard to break, you know. Maybe that's the way. Maybe that's the segue of getting there. But if you write good code, I don't see a reason why you wouldn't do it. The only reason is some other people don't know it. Then do the pair programming with them, do the sessions, do the, you know, encourage them into understanding not the value, but how to actually do it. And things will hopefully work out. The team can still decide not to do it, but then, you know, the first incident happens, the fence, maybe, you know, I don't know, maybe you need to stay longer because things break in production. That's the moment you actually really consider them. And that's when you say, hey, if we wrote tests, it wouldn't happen. How about we start with tests this time? It doesn't work if you enforce them, if you tell them write tests. That doesn't work. They need to see the value.
Do you think that if it doesn't come from management, that no one would do it? Like if it doesn't come from management, then no one actually follows it.
I hope I reject to believe in this, because then we're doomed, you know. Then I find it not being professional, to be honest. You know what I mean? I think, like, do you ask a surgeon to clean his hands before he does the intersection of someone's body? No, you just need to clean your hands, right? It's the same. Being a professional developer means you do right tests. I don't want to call people unprofessional, please don't get me wrong. But I'm just saying, you know, it's part of your education. It's part of getting better, you know. Like being senior developer, you write tests, you know. You're just being professional about your craft.
Okay. Hey. So. Okay. So. Agent
we
R.
have Agent. Yeah.
Yeah.
Here we go.
Agent R. Do you have a question?
Yes. Hi, Greg. Thanks.
Hello.
This
Hey.
is such a great topic. I mean, I'm happy here just listening to you talk, you know, and give all these points. I have a question. You said that tests are hard, right? So a lot of people don't want to do them, but how do you start thinking of writing those tests first before you start even writing the code? It's so difficult to get into that mentality that is like, I don't find an easy way to segue into that. Yeah. Is there a way that some pointers that you can give us?
Yeah. It's a very common thing. So you see, very often developers will come and say, you know, do you do TDD? Well, no, why not? I don't know what I want to write. Yeah. So yeah, that's a sort of a problem. And it is a problem. So I would start with the first thing. You don't need to write that test. What you can do, what I encourage people to do is create a describe block, create a it test case, and write a comment what you want your code to execute. Just a comment, no code, no testing code. Just do / and say given, and then you say, oh, you know what? Actually, you should start with when. Start with / when. Then you say what you want to execute. Do I want to dispatch the action? Do I want to test some method? Do I want to click some button on a component? Do I want to call a service? What do I want to do? Okay, you say when. You have a when case. Okay, cool, fine. Then do the then case. Do / and write then. And then you say, then what? Okay, if I click the button, then the service should be called. Then the action should be dispatched. Then something should happen. Okay. If when I call a service, then that request should be executed. Okay. When I call that action, then my UI should get that selector. Then it should get this object. Then this method on the service should be called. With that setup, you are 90% there. And then you say, okay, you just uncomment that code. You can leave the comments, of course, but then just write that pieces of code, right? So when I dispatch the action, and then you will see in your IDE that you're missing parameters. You're missing that parameter of the action. You're missing the parameter of what button you actually clicked. And you put it to the given stage, and that's it. And the test is done.
Wow. Thank you.
Happy to help. This is really great. You guys have questions. Normally people don't ask anything, so that's really awesome.
Well, my question is, if no one's in the team knows how to test, and then
Yeah.
well, for in my company, like no one knows how to write tests, and then someone's want to try, and then they struggle a lot. So
Yeah.
I mean, getting a consultant to teach us is not an option because no budget. So what is your advice?
Yeah, so you need someone who's really passionate about it and want to commit to it, and just, like, it's the same when you were writing code, you didn't know how to write code, then you just persevere, right? You got debug errors, you just have to go through it. I would not advise the whole team to go around it. Just find the ambassador, send it to me. I'll be happy to help. I'll be happy to, look at your test cases and just give you a very short pointers of what you should do and examples. So for sure, I mean, I'll do it for free. No, absolutely no problem. I'm happy to help. So generally get one person who will be the ambassador and evangelist of tests, and then get them to, learn, read video, watch videos, read about it, read the book, commit to it in some period of time, maybe a month, maybe or two, but you will see the results very fast. And then let them actually experience the journey of the spiritual journey of writing tests. That's it's very fun, actually. When you learn it, then you say, like, let me tell you this. Okay. Every single developer to come to our company says, I don't like writing tests. So, no, well, they sort of like, but I don't know how to write tests. And everyone is like, why do I have to do all this? But no one after 3 months wants to write the other way. Every single one says, there is no way back. I want to go like this. I stay on it. So it's funny. I don't know how it happens, but it's true. Everyone is like, I don't know. Then you spend time with him per programming, 3 months after, he's like, of course I'm not coming back. And it's actually very interesting because, the funny thing is there is a huge retention in our market, right? Developers come and go, they get a better job offers, they do all the stuff. But people who are in our company, they are for the reason. They are for the reason because they know if they go somewhere else, they have those problems. People don't write codes there. So they stick with our company for longer because they just like, what am I going to do? I'm going to go to the company and they don't write tests. I don't want to do it. I want to stick here and work here. So it's also interesting, argument for your management, why to invest in testing. Because, very often people come and say, hey, I'm not going to write tests. No, like the management says, don't write tests, tests are slow, like our clients don't pay for tests. That's not true because your clients pay for working software, right? So, yeah, sure. I mean, what you're going to do, the funny thing is how it works. When you start without the tests, your progress on the beginning of the project is very high, and then it stabilizes and sort of plateaus. You can't just move forward. And this is the moment when developers leave and go and find another job because it's not cool to work on that code base. Now, if you write tests, you're slower but steady. And steady wins the race eventually. And eventually, after some period of time, you are a lot more predictable with your estimates because you know where things are, you know how it's tested, you just know. It's easy to introduce people because the code is cleaner, and you are constantly improving your project. You just get better at it, you know. And with the no code, no test approach, you explode in the features within the first couple of days. Then no one knows what is happening. You start knowing what, and then you come to the business and you say, I want to refactor the whole code base. And they see these dollars, you know, in front of them, and they say, oh my God, that means it's like hundreds of thousands or million of dollars I have to pay for this. Why couldn't you write it from the beginning? Well, you could if you did TDD, because in TDD, you refactor every 5 minutes, every 30 seconds. The refactor is never a big thing. You never refactor. Unless you like really restructure because, I don't know, you want to use a new state management tool or whatever. Okay, that's the refactor, but that's a technical decision. It's not because the features are not working anymore.
Yeah, and then so if you don't test also, you can be fast, but then, and you're saying that the customer didn't hire you to test, but he did hire you to test, because the problem is that if you don't test, you're going to encounter bugs and you're going to spend more time even in development.
That's
And
the point.
it's still going to incur costs, right?
Yeah, absolutely. It's hidden cost. You know, no one talks about it. But then look at the projects. Actually, Kent Beck, the guy who actually is behind the TDD, he was working in Microsoft, and then he did those case studies. He went into teams that were doing TDD and the ones who were not doing TDD, and then the ones who were doing the TDD. Eventually, projects cost a lot less than the ones who were not doing, because exactly as you said, Agent. I mean, it's like, you know, when you Formula One racer, right? It's not the point to actually put the pedal to the metal, right? You have to brake at some points and do turns and stuff. It's not a drag race. The same is with the coding. It's don't put the pedal to the metal, just be wise about it.
Agree.
So does anyone have any question for Gray? Any comment?
Greg, do you have the slide deck link, or?
Oh yeah, sure. Let me just share it.
If you can post it here, that would be great. Thank you.
Yeah, absolutely.
I missed the whole presentation. I wanted this presentation so badly.
I think it's recorded, right?
Huh?
I think
Yes.
it's recorded.
Yeah, it's recorded,
Yeah.
and it should be ready maybe tomorrow or Friday, and then it will be uploaded to YouTube channel by me or Bonnie.
Awesome. Can you see it? Are you able to see?
Yes, I got it.
Okay, awesome.
Yeah.
But guys, if you ever have any problems with tests, please do reach out to me. I'm really eager. Like, I'm on my mission getting tests. You know, the first candidate. It's actually one of our values at Cobiro. So yeah, please do reach out. I mean, it doesn't take much time, but yeah, happy to help.
So if there's no more question or comment, then
Simon, actually, sorry, just to interrupt. Simon, this is actually not my Twitter. It used to be my Twitter, but I forgot the password. It got blocked. Forget about it. You just have to do this, the underscore in between my name and surname. So sorry for that. That's no longer my Twitter.
yeah, I follow your Twitter and then I retweet what you tweet. So yeah. So
yeah, thank you for that.
Yeah, I mean, even your tweet is full of like tips. So people, please follow Greg's Twitter and read like most of his messages, or all his messages. Yeah. So it's okay. So thank you, Greg, for coming. And Bonnie couldn't join, but she says she knows your talk will be great, and she can't wait to watch it later. Yeah. So thank you so much, Greg.
Thank you very much. Thank you, guys. Have a nice day.
Yeah.
Thanks, Greg.
Yeah. And I can't wait to
Thanks,
invite
Greg.
you to come back in 2022.
Finish.
I'll ping you later. Yeah,
Bye, Greg. Thank you very much.
thank you.
Thanks, great.
Bye.
I'm bowing over here, Greg. So
So thank you. Yeah. Now let me screen caps. Okay. Okay. So yeah, I'll see you guys maybe on the December 29th. So the last talk of the year, like in Angular APEC. So yeah, bye everyone.
Bye,
Let me
Connie.
yeah, bye.
Bye.
Let me stop the recording.